Before I jump into the main topic, here is an important detail. If you are preparing for a tech role, then you must choose a solid career track. Visit sanfoundry.com/training to know more. Dear friends, let's look into one more problem, and this is a very good problem for our understanding of pointers, the address of a variable, as well as the power of programming that a programmer can do, right? So programmers at its best, basically. So this is a really good example where we are not bound by the programming language compilation things. Okay, we are really bound by our way of thinking, programmers' way of thinking. It is a really good example. Okay, so let's try to see what is in store in this example for us. So here I have, you can see, I have a variable integer which is having a value of 100, and then I have a pointer p which is nothing but pointing to a integer, right? So it's a p, it's going to store an address of a integer or integer variable, right? So in the next statement, we are trying to initialize this pointer is storing the address of an integer a, right? So I think these are the only two lines which are important for you to understand. You have a variable, integer variable, and you have a pointer to that integer, and then storing the address of that variable, right? So you are going to deduce and tell what should be the output for this, right? So many of you might get confused about these kind of notations. Okay, so here you can see, right? You should not dread, you should not worry. See, the idea is you know what you want to do in your program. Simply go ahead and do that. Okay, whether this is valid or invalid is a secondary thing as a programmer. If you know what you are doing, most likely compiler will understand what you are doing. Right? So let's pause this video, and as a customary, you have to analyze the code. Please analyze the code. This is very important. You might, as part of analysis, you might think that it's a valid statement, or you will have some compilation error, or you might have a runtime error, right? So you must analyze the code. Analyze the code, and then if you have a machine with you, you should run the code. Okay. So whatever your understanding is, try to make sure that whether the output is showing your understanding, right? If it is not so, then we have to figure out what's wrong. Okay. All right. So now I'm going to jump into the lab, and then I will explain line by line what I have done and what will be the output of this code. Okay. So let's go into the lab for this particular sequence. So I am here, and we have our program, right? Okay, so you can see there, let me put a new lines basically so that it's easy on the output, right? Okay, so I'm going to run this code first. I'll compile this and then I'll run this, right? So let's compile this first. So compilation was successful. If you have a compilation error or warning, it's always good to solve it. Sometimes the warning can be genuine, it's intended, right? So we don't have to worry about it, but compilation error generally you should solve, right? All right, so we have compiled it. Now I'm going to run it. So your guesswork or your initial analysis will be validated here. So I'm running the code, and there is absolutely no errors. There was no warning, and the runtime is perfect. Okay, so runtime is giving me 100 and 100. Maybe some of you have got it really right, and maybe many of you actually. But some of you who have not got it right? So I'm going to explain it, what's happening, what is the phenomena, right? What's happening here? So let's look into this particular, example further, right? So what we are doing here is you have an integer a equal to 100. So there is a memory location a and the value at that memory. So what is a? A is a variable. So variable always have two things, as I told you in my pointer class, right? There is an advanced pointer tutorial which I have created. I think you should watch it in case you have doubts and queries on pointers. Okay. So variable always have two things. A variable has an address and a variable has a value, right? So the value is 100. So by doing this, we are saying that value at location a is 100. Correct? That's what we are saying. And then A also has an address, right? So it has an address. So location, A has a location, it has an address. Now what we are doing is P is storing the address of A. That's the important thing. What does P do? P stores the address of A, right? So just for our discussion, suppose I could do a runtime, okay, that's not a problem, but I'm just explaining. Address of A, suppose it is, okay, it's a supposition, right? Suppose it's 1000, right? Hexadecimal 1000. Similarly, you have another variable called P. So P also stores a value and P also has its own address, right? So consider that address of P is hexadecimal 2000. Again, it's a fictitious. I can easily run this code and display the addresses, but I think every time when you run the code, you will see it's a very large address and it changes also, right, during runtime. So during every invocation it can change. So best is to understand like this, okay? So what is value? Value at P, value at the location P is nothing but hexadecimal 1000. Because it stores the address of A. Address of A is 1000. So we say P equals to ampersand of A. So P is storing this. That's the real thing, right? So value at P is this. Address of P is suppose this. Okay. And then suppose this is an example, right? Okay. Done. So let's try to see what we are doing here. What we say, we want to do a printf. Perfect. What do you want to do? You want to do a star and an ampersand A. So don't get worried there. Okay. Don't get worried. Simply look into star ampersand A. So when you look into star ampersand A, star ampersand A. So look one by one. Do a star and then put some ampersand A here. Okay. That is as simple as that. Okay. So continue with the star and then you say ampersand A. What is ampersand A? Ampersand is an address of A, right? What is address of A? It's 1000, okay? So when you say address of A is 1000, what we are saying that you don't want to display the address. You say jump to that location 1000 and give me the value there, okay? So if you are jumping to that location 1000 as per this logic, right? Suppose you are jumping to this location 1000, right? And then it's indirection, right? So go to that location and give me the value. So what is stored in that address 1000? Value stored is basically 100, right? 100 is stored. So that's how you see it, right? Or in a short way, we can say that, we are kind of negating these two. And this is negating means we got the address, we jump there. So it's like negating each other. And then we got the final thing as A itself. And what is A? A is 100, as you know, right? You can look at two things. This shorter thing which I told you is not always true because there can be many things here. So this is the best way to learn actually, right? So follow this path. Okay. Yeah, this path is a better path, right? Okay. So you get the value 100 here. Let's look into this. Again, it looks like a double pointer and whatnot actually. Okay. So why are you worried about double pointer? Don't get worried. Okay. Just don't get worried. In fact, compiler sometimes will throw a lot of warnings saying that this is a mismatch, issues are there, but programmers are supreme in C language always. So you might have a logic in your code where for a single pointer, you are really thinking of a double pointer and it may be perfectly fine for your logic. Compiler will definitely give you some sort of a warning. It won't give errors actually, okay, because compiler knows that there's something wrong, but maybe the programmer is thinking something else, right? So those possibilities exist, right? So that's what I said. You should not get worried about pointer, double pointer, and then, addresses and indirection. As long as you know what you are doing, you pretty much are right. Let the compiler think otherwise, okay? So compiler can think otherwise. So star, ampersand, P. How do you break it actually, right? So we'll do a star and then we put an ampersand P. We put a bracket, okay? So I'm going like this actually, correct? So just think for a moment, what is address of P? I have written address of P is just 2000, okay? So we are going into a star and then we say 2000. So now what does it mean? Put one star now, take one star, right? So there are two stars. So now we'll try to solve this person, right? This area. So we'll say star and then put a bracket on this. See, this is fairly simple actually, okay, in terms of our logical understanding, right? So you say, okay, I got an address. This is, I repeat, this is hexadecimal. I have not written hexadecimal. Maybe I should write it so that, you know, you have more clarity, right? Okay. Yeah. So this is hexadecimal 2000, right? So when you say go to that location 2000 and jump to that location, go means simply say jump and get the value. So at the location 2000, jump and get the value. Star means get the value. The value at the location 2000 is hex this 1000, right? So you can see that. That's what I have noted down here, and I think your logic will also say the same, right? So we are simply replacing that hexadecimal 1000 here. So, okay, so I repeat this thing. Sorry, this thing is now just hexadecimal 1000. Star is as it is, this one leftmost guy, right? So from double pointer we became a single pointer, or two level of indirection we did already one jump. Now we have to do another jump. So as I told you, what is the another jump? I think another jump is fairly simple for you now. Okay, you know that it is hexa 1000, so that's the location. Jump there and get the value. Because why to get the value? Because we are not interested in this, we are interested in this star. Go and get the value. You already know that in the previous assignment, in the previous part, you know, when you go there and jump, you get 100 here, right? Because this is 100, right? So you are getting 100 here. So essentially what has happened is, whichever method or mode do you choose, right? Basically, you are getting into the right direction. Okay. So as I told you, this is a very nice example for people who are kind of worried about pointers a lot. Okay. You should not be worried about pointers. Try to see this video once again in case you have a doubt. I think I have given a lot of explanation around it right now actually. Okay. Some of you, see, I have given one example about hexadecimal 1000 and 2000. Some of you say, no sir, I really want to know the addresses. What addresses they are at, you know. What is the address of this A and then P, right, basically. I can display it, I don't have a problem, okay, but this is very easy for you to understand in terms of concept, right? So if you are still interested, I am modifying the code live now. I will show you the address, okay. So I will show you the address. It's pretty simple. So we are putting the value. So let's try to write this code, okay. So I'm just modifying the code. I will say, okay, I'll put at the end, right? Okay, so we'll say printf, and then I'll say address of A is, right? So what is the best way to print an address of any data type in C programming language? Is it %x, %l, d, u, p, whatever you want, right? Okay, so I think the best option is %p, as I think some of you have already know this. So you simply say address of A. That's it, right? And then what do you want to do? Want to print an address of P? So address of P is %p, and then you say P, right? I think it's as simple as that. Now I'm compiling this code once again for you, and you can see the addresses, right? Compilation is successful, which means %p is good. Use it, run the code. And as I told you, this address is going to be really a big virtual address. Remember, most of the addresses, not most of the addresses, every address that you see in your user space at this point of time, right? They are all virtual addresses. And then some of you are fond of kernel. Yes, kernel also, almost all of the addresses that you see, almost, right, are still virtual addresses, okay? So because we work on a virtual platforms or virtual, you know, operating system environments, right, basically. So these are virtual addresses. You can see, so this is A and then this is P, right? We can run once again, and then you think that it is going to be fixed. It is never true. You can see the compiler gave me another runtime, okay? Another runtime, you get a slightly different address. So it is very difficult for us to, you know, create some understanding and then try to make sure that, you know, basically we get a slightly different, you know, output all the time, right? Okay. So the best option is for us to make sure that we try to draw some diagram, or, you know, the way I have explained here in this explanation, right? Okay. I think this is sufficient for us to understand the concept at this point. Yeah, you're always free to, you know, display the addresses, and then by looking at the address, some of you can easily say, oh, this address is in the stack, okay? So this is the way a system programmer will look. When you're focusing on some of these core things, right, Yeah, this is an address on the stack. Okay, but that's a topic of some other day actually. All right, so thank you very much for patiently listening to this particular code snippet and the video and the explanation. I hope you liked it. I will see you in another video. Thank you.